Hello, welcome to 9.1 Inverse and Joint Variation. So, to start off, we're just going to review a little bit. Now, this stuff shouldn't be new, because we should have heard direct variation before. That's just if y equals kx, where k equals 0, then our y varies directly with x. In this k value here, that's just a constant. Or another word that you may use is rate of change. So this is like our slope, because if we remember what our equation is before, it was y equals mx plus b, our equation for a line. So for direct variation, that is when it's just a linear equation that starts off at 0, 0. So that's when this b value, it's just when our b equals 0. So that would just leave us with y equals mx, which if you look at your equation, it's very similar to y equals kx, and they are the same thing. This m, that is just replacing our k. So our m, that's like our k, so this is our slope, which is another way to say rate of change, which is our constant. Okay, so this k is going to be in all of our equations that we will be using, and it's not going to be a letter all the time, it's just going to be a number. Okay, and it could be a fraction, it just depends on the problem. So what's new is inverse variation. So that's if y equals k over x, where k does not equal 0, then y varies inversely with x. Okay, so that's the one difference. So x is in our denominator if they are inversely related. Alright, so if we move on to classifying direct and inverse variations, what's important about this is you have to get y by itself on one side. Okay, so to classify, y must be alone. Okay, so for this example, we'd have to multiply both sides by 5 to get y by itself. So that would give us y equals 5x. So, thinking about our equations, does that follow our y equals kx or y equals x over k? Or excuse me, y equals k over x? Well, it should be y equals kx, so this is a direct variation. Now, looking at this next one, get y by itself, so y equals, subtract over your x, negative x plus 5. Now, does that follow either one of our equations? Nope, so this is neither. Gotta look out for that. And then for this last one, we divide both sides by 5, so that gives us y equals, divide both sides by x. And so that would give us y equals 5 over x. So this would be our inverse. Okay? So in order to do this, our y must be alone. That's the biggest thing. And if our x is just being multiplied by our constant, it's direct. If our constant is being divided by x, it's our inverse. And it's not our second equation because our b value is not 0. Alright, so for writing inverse variation equations, the variables x and y vary inversely, and y equals 8 and x equals 3. So it's telling us that it varies inversely, so we have to think about what is our inverse variation equation. Well, if we look above, that is our y equals k over x. So, using this outline, using this formula, all we have to do is plug in our y equals 8. So we just plug that in for y. When we plug in our x equals 3, we plug that in for x. So it'd give us 8 equals k over 3, because the only part of this equation that we're missing is our k. And that's what makes each inverse variation or direct variation unique. So, to get our k by itself, we multiply both sides by 3. So that would give us 24 equals k. So we found our k, but we're not done yet. Now we have to write our equation out. So all we have to do is plug this 24 into our inverse variation equation. So that would be y equals 24 over x. And this is our equation. So when it says for part B, find y when x equals -4, we're using this equation. We want to figure out what y is. It tells us what x is, -4. We just plug that in. So y equals 24 over -4, so our y equals -6. And that is our answer. Okay, so let's flip the page over. So it says, now we're going to look at a table, and from the table we can decide, or we can determine if it's a direct variation, an inverse variation, or neither. Okay, so as we go through this, we have to look at, well, which order is it going in increasing order or decreasing order from our x's? So looking at this, starting at 5, going down to 4, going down to 3, well, that's decreasing. And from our y at 20, 16, 12, that's also decreasing. So at this point, since we have two arrows pointing down, since both of our numbers are decreasing, that means it can't be an inverse. This must be direct. But we don't know for sure. We have to prove that it's a direct variation. So to do that, we have to plug in, we have to test a point. So plugging in, well, 2 points to test to see if this is a direct variation. So if you recall, our equation, if it's a direct variation, is y equals kx. So we just test out 1 point. So I'm going to choose 5, 20 to test first. So I'm just plugging in 5 and 20 into my x and y and see what I get for k. So that would give me 20 equals k times 5. So when I solve for my k, I get k equals 4. Now, if this is a direct variation, if I test another point, I should get a k as 4. So let's try for 16. So plugging this in again, I get 16 equals k times 4. So I end up getting k equals 4. And that's what I want. I want the same k for both. And since I do, that means it is a direct variation. Okay, now if I were to get two different numbers, that would be none. Alright, let's look at the second one. So we're starting at 1, 2, then 4. So in this case, we are increasing. And then we start at 20, 10, and 5. So then that means we're decreasing. So in looking at this, we have increasing and decreasing. Since we're going in opposite directions, that means this could be an inverse problem, inverse variation, but we have to test it just like before. So our equation for our inverse variation is y equals k over x. So just like we did before, we have to test 2 points. So let's test out 120. So we're just plugging this in, so we'll get 20 equals k over x. So that means k is 20. And let's test out another point, 210. So I'm going to test out 210. So that gives me 10 equals k over 2. So my k is 20 when I multiply 2 over. So I have the same thing, which is what I want. So that is an inverse variation. Now looking at this third one, we have 2, 6, and 4. Wait a second, that's out of order. If this ever happens, you have to rewrite this so that way our numbers are in either increasing or decreasing order. I'm going to take this 6, and if I take my x, I'm going to have to take the y with it, and I'm just going to rewrite it down here as 6 and 20. So that way they're all in increasing order and or all in decreasing order. So crossing that off so I don't get confused. So now looking at this, I have 2, 4, 6, that is increasing. And then I have 10, 15, 20, that is also increasing. Since both my arrows are pointing up, that means it could be direct. But I don't know, I have to test it. So remember, y equals kx. Let's test 2 points. So I'm going to test 2, 10. So plugging this in, I get 10 equals k times 2. So I get my k is 5. So let's test a second point. And any of these, you could choose 415 or 620. I'm just going to do 415. So 15 equals k times 4. So k equals 15 over 4. Ooh. Now these aren't the same, so this is neither or none. Okay? Since these are not the same, that means it's not a direct or inverse variation. Okay? So now, here's some more new stuff. Our joint variation, so that's if, and that's just throwing in a third variable, z equals kxy, where k does not equal 0, then z varies jointly with x and y. So the only thing that we're adding on here is we're adding on this third variable z, and the y is now multiplied by our k and our x. So, reading our first example, it says the variable z varies jointly with x and y, and x equals negative 12, y equals 4, and z equals 2. And it wants us to write an equation relating y and z. So, what this is saying is it just wants us using our equation that we learned above. So z equals kxy. It wants us to plug everything we know in to solve for our k so we can write our equation. So just like we did last time, we're going to plug in our 12, plug in our 4, and plug in our z. So that would be 2 equals k times negative 12 times 4. This gives me 2 equals negative 48k. So that would be k equals negative 1 over 24 when I simplify. But I have to plug this into my equation to get z equals negative 1 over 24 xy. And this is my equation. So when it says find z when x equals 4 and y equals negative 7, that's just plugging x and y into my equation and solving for z. So I have my z equals negative 1 over 24 times negative 4 times 7. So my z ends up being 7 over 6. Now make sure you can do this on your own, and when you put this in your calculator, you should put parentheses around your 1 over 24. Or negative 1 over 24, rather. Okay? So, for our last bit, it says writing different types of variation. So, this is just practice. So, if it says y varies directly with z, using what we know, so y, that is going to vary directly with z, so that's going to be y equals kz. And then if it says x varies inversely with y, so whatever letter is out front, that goes on the left side of the equal sign. So x is going to equal, and it says inversely, so I know my constant's going to be on top, and my second variable is going to be in the denominator. So x equals k over y. And z varies jointly with m squared and n. So varies jointly, so that means I'm going to have two variables, z is on one side, the other two on the other side with our constant. So z varies jointly with our constant times m squared times n. And then for our fourth example, y varies directly. Now this one's a little more tricky, so we know y varies directly. When it's directly, that means our constant's going to be multiplied by whatever it's directly, varying with. So that would be kx squared. But it also says it varies inversely with z. So that means in our denominator we have a z. So it varies directly with x squared and inversely with z. Now, that is it for our video. One thing that I would like you to write with a little star at the bottom of your paper is k is in all of these equations, or k is in every equation. If you write that, you'll get full points for your video. So, I will see you in class.